So yesterday we went over the first couple of problems. Remember we did one together and then you guys did one by yourselves. But basically the idea is that we were looking at an overall population. So for Northbrook Middle School, it has a population of 300 students in the 7th grade. And then it had a breakdown of how many students had an A. So 80 students had the A range, and 140 students had a B range, 60 students had a C range, and then 20 students had an F range. So based off of that, we wanted to identify which one of these classes best modeled what we had going on up here. So we first broke it down, okay, let's start with the A's. We knew that there were 80 students in the population out of 300 that had an A. That was able to convert to 27% because we just did 80 divided by 300. When you multiply it by 100, you get your percentage. So we found that Barbieri's class was kind of close with 29%, and McNeely's class was right on with 27%. The rest of them were further off with 33 and 7%. So we were able to get rid of those two. Okay, so then we went down to the B range, 140 B's out of 300, and then multiply that by 100, we get 47%. Barbieri's group was only at 35%, so we could get rid of Barbieri's. McNeely's was exactly at 47%. So we understood that McNeely's percentages replicated what the population's percentages were. And that's what we were looking for best representations. They either are mirrored, exact, or extremely close, very close to it. So that's what you're looking for. So that's what we did also for problem 2. Same idea. Found the percent of the population, or the percent of the bag that was red. There were 250 red out of the 1,000 marbles. So we did 250 divided by 1,000 and then multiplied that by 100. We got 25%. And so we were able to find that round 2 and round 3 were the only ones that had 25%. The others were at 0, 13, and 20%, very far off. So we were able to cross off round 1, 4, and 5. So then we went to the blue marbles, 290 blue out of 1,000, multiply that by 100, we got 29%. And the only one of the rounds that was close to that was round 2 at exactly 29%. So we were able to get rid of round 3. Okay, so you want to make sure that you understand how to relate those back. So again, round 2 is the round that was the closest to the population. All right, so moving on, let's take a look at problem number 3. Problem number 3, there are 250 people that were surveyed about their favorite color. 14 people said yellow, 32 prefer red, 64 prefer purple, 46 prefer blue, 54 prefer orange, and 40 prefer green. If you surveyed 32,000 people, then how many would you expect to choose purple? So we're focusing on just the color purple. That is our focus. How many people chose purple out of our survey group? 64. So we know there's 64 people that chose purple out of how many people? So it was 32,000 people, only 64? No. That 64 doesn't belong to the 32,000. That 64 belongs to the survey group. How many was that, Angel? 250. There's 250 people that were surveyed. So 64 people liked the purple out of the 250 that were surveyed. Okay, that's the total amount that was surveyed. What we want to do is we want to make a prediction. We want to estimate or predict out of 32,000 people. Okay, so I don't want to know, blue or yellow. I want to know how many liked purple out of a new amount of people. So we're going to do X over 32,000. Okay, so we're just setting up that proportion so that we can do that cross product method again. Vincent, what you doing? In your desk. Okay, so we're going to go ahead and multiply 250 times the X gives us our 250X. Then we're going to multiply 64 times 32,000. Okay, so if we do 64 times 32,000, we're going to get 2,048,000. but we're not done. I need to know how many people wanted purple. I've only created an equation. What's the last step that I need to do to solve that equation? Sophia? Divide. We need to divide. We're going to divide both sides by that 250. Okay, and we'll find that 8,192 people would prefer purple. Okay, I want you guys to try the same process again. You're going to mirror it on problem 4. You're going to mirror that process on problem 4. So go ahead and turn your papers over to problem 4. Okay, who can raise their hand and tell me what did they get? If we've got this many people that were surveyed, we have 500 people surveyed, we have 88 students that preferred math, 120 that preferred science, 102 that preferred language arts, and 186 that prefer social studies. If we've got 9,000 students in the Peachtree Ridge cluster, then how many would you predict prefer social studies? Who wants to share out what they got? Or I can call on somebody randomly. Or Michael. Michael, you can share. What'd you get? 3,348. Very good. So in the question says we're focusing on what group? Social studies. We're just focusing on social studies. So that means I'm going to set up a proportion of 186 out of the 500 people that were surveyed. We have 186 people who prefer the social studies out of the 500 people that were surveyed. We want to know how many want social studies out of the 9,000 people that are in that cluster. Okay, so we've got 186 over 500 equals x over 9,000. We then do our cross product. We're going to multiply the 500 times the x, and we get 500x. We'll then multiply 186 times that 9,000. 186 times 9,000 is going to give you 1,674,000. Okay, and then our very last step is, of course, to divide both sides by 500. Okay, and we'll get that x is going to be equal to 3,348. Okay, any questions? All right, problem number 5. I think you guys can do these on your own, but we'll do the boys' data first, and then I'll have you do the girls' data. So we want to have the mean, the median, and the mode for both data sets. So we've got a listing of boys and a listing of the girls. So to find the mean, who remembers what do we need to do in order to find mean of a data set? What is the process there? Angel, how do we find mean of any data set? Not for the mean. We don't have to do that for mean. Very good. You add all the numbers and divide by how many there are. Write that down again as a reminder. Mean. You're going to add. You're going to count. You're going to divide. For mean, you just add, you count, you divide. So we're going to take the values for the boy. We've got 12 plus 9 plus 11 plus 7 plus 11. We're going to add all those together, and then we're going to divide it by 5 because we have 5 numbers. Okay, when we add everything together, that comes out to 50. So we have 50 divided by 5, and 50 divided by 5 is just 10. So the mean for the boys is going to be 10. For median, that's different. Median has to be ordered. You have to put it in order from least to greatest, and then you can find that center number. So median is order least to greatest. And then you find the center. Remember, if there are two centers, you add and divide by 2. You're not allowed to have two centers when you're finding the median, so that means you need to find what's in between those two numbers. So you add them and divide it by 2. So here, what's the smallest number for the boys up here, guys? 7. So we're going to put a 7. What's the next number? 9. Thank you, Ezra. Next number? 11. Then 11 again. And then the last number is 12. What is our center number here? The 11, right? If we cross off the 7 and the 12, so you cross off the first and the last, then you cross off the first and the last again, you're left with just a single number in the center, 11. Okay, mode. Who can remember what is mode? What is mode, Abdullah? The most, right? Yeah, mode is most. Okay, it occurs the most or repeats the most. Repeats the most or occurs the most. So out of the numbers for the boys, do we have a number that repeats? Yes. Which number, Vincent? 11. Very good. 11 is the only one that repeats. Okay? All right, I want you guys to go ahead and do the same thing, but you're going to do this for the girls' data. Find the mean, the median, and then the mode. Mean, median, and mode for the girls. All right, Christopher, what is the mean for the girls? $10.4. Very good. All you're going to do is add these numbers together. You're going to take the 18. You're going to add it with the 12, add it with 4, add 9, and then you're going to divide that by 5 because, again, there's 5 numbers. You add the numbers, count how many there are, and then divide those two. When we add all those together, we're going to get 52, and 52 divided by 5 comes out to 10.4. Okay, 10.4. What about the median? Vincent, what did you get as your median? 9. Very good. If we put these in order from least to greatest, the smallest number is a 4, followed by 9, 9, 12, and 18. When we cross off our smallest and largest, and then smallest and largest again, we're left with just 9 in the center. And then mode, Malia. 9. 9 happens to repeat the most in the girls' data set. Now, if you look at the question right below it, it says, which measure of center is most similar when you are comparing boys to girls? So I want to know which one, is it the mean, the median, or the mode, is most similar between boys and girls. So if we look at the mean for the boys, the mean is 10. The girls is 10.4. Are those close? Yeah. Okay, what about the medians? 11 and 9. Are those closer to each other than the means were? No. What about the mode, 11 and 9? No. So the ones that are closest when comparing the most similar means closest together. Okay, most similar means which ones are closest when you compare. That's going to be the mean. Mean is the most similar because you've got a 10 and a 10.4. They're only 0.4 off from each other. Daniel, you can stop turning around. All right, let's take a look at problem number 6. What is the median for Fun Fit and for Greg's Gym? Median. Okay, so let's start with Fun Fit. Here's Fun Fit's line. Who can tell me what is the median on this graph? George. On the fun fit graph, which one's the median? 100. Very good. Remember, your median is the line inside of your box. The line inside the box is going to represent the median. So our median for fun fit is going to be 100. So fun fit median equals 100. What about for Greg's gym? Greg's gym. Azariah, which one do you think is the median for Greg's gym? Inside the box. Which one's inside the box? 120. Good. So Greg's gym, again, your median, guys, is inside of the box. The median is going to be 120 for Greg's gym. Now, there's all sorts of questions that I could ask. I could ask things like, oh, what's the difference between the medians? And if I said difference between the medians, what operation is difference? Subtraction. What if I said, what's the sum of their medians? What does sum mean? Addition. Okay, so there's all sorts of different things that they could ask you. They could say, oh, who has a larger median? Then you would know it's who. Who has a larger median? Greg's gym. Okay, so you need to know what each of these values are. What do they represent? Any questions? Okay, let's go on to the next page then. All right. So, go ahead and find the difference between the medians for Fun Fit and Greg's Gym. We're going to find the difference of those medians for Fun Fit and Greg's Gym. What operation did we say we were going to do again for difference? Subtraction. That word difference means that we are going to subtract those values. So Eileen, if we subtracted these values, what do we get as the difference? If we subtract these values, what is that difference going to be? 20. You're just going to take 120 and subtract the 100, right? We got 120 for Greg's Gym, 100 for Fun Fit. When we subtract them, we just get 20. So the difference between the two medians is 20. On the test, guys, it's not going to ask you what's the median for this one, what's the median for that one, what's the sum of the two, or what's the difference of the two. It's just going to give you a box plot, and they're going to say, what's the sum of the medians, or what's the difference of the medians? You have to know that you got to find the medians first before you can calculate. Okay? All right, let's move on then. Problem number 8. The following box and whisker plot represents the amount of time spent traveling to school by bus. So this first one is bus. By car, walking, or taking your bike. Okay, so it is 4 box and whisker plots that we are comparing. We want to know which statements are true about these box and whisker plots. There are more than one correct answer. There's more than one correct answer. So you would have to circle all the answers that apply. That means you guys have to actually read through each one of these and see if it's true or not. Okay, you have to check through every single one of the problems to see if it is a true statement or not. So, statement A, it says that the car has a greater range than the bus. The car has a greater range than the bus. So we need to find the range of the car and the range of the bus and see if that car is bigger than the bus. So let's first start with the car range. To find range, remember you have to do your highest value minus your lowest value. Let's take a look at the car. What is the highest value on the car? 20. What is the lowest value on the car? 6. So we're going to do 20 minus 6. 20 minus 6 is going to give us 14. So the car has a range of 14. Okay, then we're going to do the same thing for the bus. We're going to find the range for the bus. What's the highest value for the bus? 32. What's the smallest value for the bus? 6. If we subtract those, we're going to get 26. Is the car larger than the bus? No. So this is a false statement. It is not going to work. That will not be one of the correct answers at all. Okay, let's take a look at problem B. Problem B says 25% of the walk time is between 18 and 24. 25% of the walking time is between 18 and 24. So here's walking. Here's where 18 is. Here's where 24 is. Does this box right here represent 25%? Yes, it does. Remember, each of these points represents 25%. You have 25% here, 25% between these two, 25% between these, and 25% between here. This is 25%. This is true. You have to remember that your box and whiskers plot is split into 4 sections. Okay, let's go on to C. The interquartile range of bus is 14. The interquartile range of the bus is 14. Remember when we said interquartile range? Interquartile range is the size of the box. The interquartile range is the size of the box. So I want to know, is the size of the box for the bus going to equal 14? So here is where the bus starts for their box, and here's where the box ends. What is the highest value for that box? 20, about 20, well, I'd say 24. It's not lining up perfect, but it's about 24. What about the smallest part for the box? 10. So if we subtract 24 and 10, what do we get? 14. So did it come out to 14? Yes, that's a true statement. I promise they'll line up real perfect on the thing. George, head up. Okay, problem D. The median for the bike is equal to the mean for the bike. Median and mean. Can we find mean on a box and whisker plot? No, because we don't know how much data there was. We don't know how many people were surveyed for the bike, but we can identify symmetry. We can identify symmetry. Is the bike symmetrical? Yes. The bike is symmetrical, and if it's symmetrical, that means your mean and median are the same. Okay? So write that down. Remember, symmetry is really important to understand. The bike is symmetric. So median equals the mean. They are going to be the same. Yes? Symmetric means that if you look at your center, the left side is exactly the same distribution as your right side. Okay? So they are a mirror image. If I were to fold this together down the center, they would fold perfectly and meet Okay? All right. So, like, is the bus symmetric? No, right? Because there's our center. Okay, that part of the box is not going to line up with this part of the box. What about car? Is that symmetric? No, right? The left part of the box is not going to line up with the right side. Neither is the left whisker. The left whisker is not going to line up with the right whisker. What about walking? No. Okay, again, one side of the box is a little bit bigger, and then the whiskers are very different as well. Okay, but the bike, the left side and the right side of the box is perfect. The left and the right whiskers are perfect. Okay, so they will line up exactly. All right, so that is going to work. Let's take a look at the next one. Walkers. Walkers has a greater variability in time than bike. So if it's a greater variability, it means it has a larger range or a larger interquartile range. To be a greater variability, let's talk that through again. Greater variability means it's going to be a larger spread or a larger range. So let's take a look at the walkers. Is the walkers more spread out than the bikes? Yeah, right? Look how far apart the smallest and the largest values are. Okay? The walkers are going to be more spread out. If we do walking's range, that goes 30 minus 12. 30 minus the 12 is going to give us 18. If I do my bike range, the bike's range is 18 minus 8. That comes out to 10. 18 is bigger than 10. So yes, walking has a greater variability, a more spread out set of data than your bicycle does. Okay, let's go ahead and look at the last one. The bus has a larger median than walking. What is the median for the bus, guys? Roughly around? About, yeah, somewhere around 20, maybe 23 or 24. And then what is the median for walking? About the same thing, right? They line up pretty well. So that is not greater, right? It's not larger. They are equal. They are equal in their medians. They are equal medians. Okay? All right, let's take a look at problem number 9. Problem number 9, we want to find the mean and the median for each of the dot plots, and we're going to round it to the nearest tenth. Round to the nearest tenth. Okay? Find the mean and the median for each of the dot plots and round it to the nearest tenth. So I want you guys to go ahead and calculate the mean and the median for city A only. Just focus on city A. Find the mean and the median for city A. And if you need to, you can write up on these grids, you can write what they are again. You can say, okay, this is 30, this is 31, 32, and so on and so forth. So you can transfer those numbers up there as well. Makes it easier sometimes for you to see. But you're going to calculate the mean and the median for just city A on your own. Do that right now. All right, let's take a look at it. You should have gotten 34.9 for the mean for the data set. I went ahead and showed what you're supposed to do. You're supposed to add all the data together. Now, how did I get all those numbers? How did I know that there's a 31 and another 31? How did I know that there's two 31s, Vincent? Very good. There's two dots, right? This is a dot plot. There's two dots on the 31 mark. So that means that the 31 repeats twice. And then we have a 32. Then we have a 33. Then we have a 34 and a 34. A 35 and a 35. We've got 3 36s. No 37s. We have a 38 and a 38, and then a 39. Okay, so we add all those together. That's 14 numbers. When we add those 14 numbers together, we get 488, and then divide by 14, we get 34.8571, and it just keeps going on. We need to round to the nearest tenth, so that would be 34.9. Now for the median, here's a nice part. The dot plot already puts it all in order for you. So I just have to cross off the smallest and the largest. And I'm just going to keep going until I can get down to my center mark. So I'm going to cross off this 34 and 36, this 34 and 36. Oh, but then I'm left with 2 values left. What am I supposed to do with those 2 values again, Michael? Add these 2 together and then divide it by 2. 35 plus 35 and then divide it by 2, I'm going to get 35. So 35 is my median. Now the question says, what's the difference between the mean and the median? So what am I going to do with those 2 values? Subtract. What do I get when I subtract 35 and 34.9? Say it louder. 0.1. Okay, now the reason I said to only do city A is because city B is a little bit easier. Because what do we notice about city B? It's symmetric. So do I have to sit there and add every number together? No. The fact that this is symmetric, city B has equal means and medians. So I only have to find the median. I just have to find the middle number. What's the middle number in this data set here? 36. So 36 is going to be my median. That means it's also going to be my mean. And what is the difference between those 2 values? 0. Okay? So again, knowing if you're dealing with symmetric data makes it that much easier when you are solving for mean and median. If you know it's symmetric, you know that they are the same. Okay? If you've got that down, go ahead and turn to the next page. All right, on the next page, Jessica and Marie have the following test scores. Jessica has a 92, an 87, a 72, a 90, an 85, and an 80. Marie has an 85, 91, 86, 84, 90, and 88. I want to know who has a higher average. So when we talk about average, we can find either mean or median. It's up to you. I would go ahead and stick with the mean. Find the mean of both Jessica and Marie and find out who, let's just say who, not how, who has a higher average between the 2 girls. Go ahead and calculate the mean of both and then identify whose average is higher. Okay, so mean. What is the mean for Jessica? Jolie, what did you get as the mean for Jessica? 84.2 or 84.3 if you round it correctly, it'd be 84.3. What about for Marie? What was Marie's mean going to be, Kayron? $87.3. Yeah, 87.3. Okay, so again, if you add the values together, we take all of Jessica's scores, add them up, and we get 506. Then we divide it by the 6 scores that she has, you get about 84.3. When you do the same thing for Marie, add them all up, you get 524. Divide that by 6, you get 87.3. So who has a higher average? Marie. Marie's going to have a higher average. Now here's the big question. Let's say both girls get a 50 on their next test. Who do you think is going to see a bigger decrease in their score or in their overall grade? Not who's going to have a lower grade, but who's going to see more of a decline in their average. Don't calculate it yet. I want you to think. If both of the girls receive a 50 on their next test, who do you think is going to go down more? Who do you think, Vincent? Why? Okay, because she has a lower grade to begin with, so you think that another low grade is going to bring her down further? Okay, what about you, Ezra? What do you think?
Marie.
Why?
Because because if she has a higher grade, and then she gets a bad grade, then it's gonna go down more.
Okay, so think about it. Who's got more to lose? Marie. Marie has more to lose. Okay, it's easy to think about it. If we're dealing with, let's say somebody has a 10 in the class versus a 100 in the class. If I get a 0 on my next assignment, what's 10 plus 0? 10. And then if I divide that by 2, my grade went to a 5. But if I do 100 plus 0 and divide that by 2, that goes to a 50. So whose score dropped more? The higher score. So when you look at it, when you're looking at it, if you get a low score is going to have more of an impact on somebody who's higher. What do you think a high score is going to have more of an impact on? If I change that to a high score, let's say the next grade they get is a 100, who's going to get impacted more this time? Jessica, because she has more to gain. Okay? So when we're talking about who's going to have a greater change in their score, the higher score is going to lose more from a low test. A lower score is going to gain more from a high test. We'll go over that in just a second. All right, let's go over. Let me show you exactly what it's going to look like if you add the 50 so that you can see what I mean when I tell you that it's going to have a bigger change for Jessica than it does for Marie. So if you're taking a look at Jessica, her scores were originally a 92, an 87, a 72, a 90, an 85, and an 80, and now she's going to get a new test score of a 50. So this time, instead of dividing by 6 scores, we now have 7 scores that we're dividing that by. When we add that 50 on, that's going to give us 556. We'll divide that by 7, and it comes out to about 79.4. So her score decreased, right? She went from an 84.3 to a 79.4. It decreased, you should be writing that down, it decreased by about 4.9%. Decreased by about 4.9%. Then we're going to go ahead, because remember, we're wanting to see who has a greater decrease. I don't care about what their score was. I want to know whose score went down the most. So now we're going to look at Marie. So again, for Marie, her original scores were 85, 91, 86, 84, 90, 88, and now she's also got a 50. So we're going to add all that together and then divide that value by 7. When we add all of it together, we're going to get 574 divided by 7 comes out to an 82. So Marie decreased. And she decreased by 5.3%. So she has a larger decrease. Even though her score is higher still than Jessica's, her score is still higher than Jessica, but she showed a bigger drop in her score. So Marie decreased more. You need to make sure you understand how to do that. Okay, lower scores have more to gain from a high score. Higher scores have more to lose from a lower score. All right, let's take a look at problem number 12. You're surveying to find out what students are doing for spring break. We want to know which population would provide a random sampling. We want to know which one's going to provide a random sampling. So we need to understand our sampling methods. If I survey all the students in 8th grade, that is not a random sample. That is a convenience sample because it's focusing on just one group. This is convenience. Remember, convenience is not a good thing, so we cross that off. That's not going to be a good one. If we survey all the students that ride bus 17, that is also a convenience survey. Not a good representation. All the students that bring their lunch to school. Again, we're focusing on just a single group. That is a convenience sample. Not a good representation. If we survey every 10th student that walks in the cafeteria, that is systematic random. Every 10th, the idea of every 10th creates that system, that rule, and the randomness is created by the students walking in. So that is the best method. You want to look for randoms or systematic random. Anytime you see somebody saying we're going to do this randomly or systematically by following a rule, a pattern, those are the best methods. All right, number 13. You guys can do this one on your own. I want the difference between the means. So what do you need to find first?
Median.
Not the median. The mean. You need to find the mean of each data set before you can find the difference. Find the mean of each data set and then find the difference. So for the, Okay, so for the airjet, if you add them all together, remember we've got 2 plus 2 plus 3 plus 3 plus 3, because there's our 3's, plus 4 plus 4, plus 5, plus a 7, plus 8 plus 8. There's our data set. We add all that together, we get 49. There's 11 numbers, so we divide it by 11, and that's going to come out to 4.5 or 4.45 if you round it to 4.5. For the cross-country airlines, do I have to do that same thing? Do I have to add them all up and then divide by 11? Why not? It's symmetrical. This is symmetrical, so the center value is 5. That means that the mean is also going to be 5. I went ahead and did it anyway just to show you that, yeah, if you add them all together and get 55 divided by 11, it's going to be 5. But you don't have to do that because it is symmetrical. That means that the median and the mean are going to be the same. And then they said the difference. Difference means you subtract. So we subtract the two values. You should have gotten 0.5. Okay, take a moment to get that down if you don't have it yet. Bless you. All right, let's go ahead and go on to the next. All right, for problem 14. For problem number 14, you have a listing of students that have a preference or voted for a certain type of pizza, and there are 950 students in the school. So we want to know, based off of that, let's make a prediction of how many of those students would like pepperoni, how many of those 950 would like cheese, how many would like Hawaiian, how many would like veggie, how many would like the works. So you're making predictions. So let me just remind you one more time how you set that up. With pepperoni, we know that there are 10 people who chose pepperoni out of how many total people did it survey? Find that total. How many total people surveyed? 30. Right? Our total number of people that surveyed were 30. 30 total people surveyed. It even says it up here in the problem. 30 total people took a survey. Okay? So we do 10 out of 30. We want to know how many out of 950. So you do your cross products. We multiply 30 times the x and get 30x. We multiply 10 times 950, we get 9,500. Then we divide both sides by 30. And we'll get that x is approximately 317. I have to estimate it, okay, because we're talking about people. I want you guys to do the same thing for cheese, Hawaiian, veggie, and the works. Okay, let's take a look at it. All right, for cheese, there were 6 students that chose cheese out of the 30, so you do 6 over 30 equals x over 950. Cross product, you're going to get 30x is equal to 5,700. You would then divide both sides by 30, and you should get x is equal to 190. For the Hawaiian pizza, there were 7 out of 30 that chose Hawaiian, x over 950. When you do your cross product and then divide, you get about 222. For the veggie, you should have had 3 over 30 and x over 950. When you cross product and then divide, you get 95 people would choose the veggie. And then for the works, there were 4 out of 30 who chose the works, so x over 950. Cross product and then divide, you get x is approximately 127 people who would choose the works. So make sure you've got that copied down, and then let's go on to problem 15. Okay, for problem 15, there are 420 players in the league. Based on the sample, how many players in the league have rushing yards that are less than 1,000? Less than 1,000. Okay, so what we want to first do is identify what each of these bars represents, like how many players each of these bars is going to represent. So let's talk about this first bar. What value does this first bar go up to? What value does that first bar go up to? 3. So I'm going to put a 3 inside. What about the second bar? 3 as well. What about this third bar? What does it go to? 5. This fourth bar? 4. This long bar? 12. Bar next to it? He was doing the last one. 7. And then the last one is a 1. Okay? So that means that we have a total, this represents the people that were surveyed, we have a total of 3 plus 3 plus 5 plus 4 plus 12 plus 7 plus 1. That is a total of 35. Okay, it has a total of 35 people who were surveyed. Now, we want to focus on the amount that is less than 1,000. Less than 1,000. So that's when we have to zoom in on these values on the bottom. These values represent rushing yards. So what this means is that 3 people had between 0 and 249 rushing yards. 0 to 249. Is that less than 1,000? Yes. So that works. What about 250 to 549? Is that less than 1,000? Yes. 550 to 749. Is that less than 1,000? Yes. 750 to 999. Is that less than 1,000? Yes. 1,000 to 1249. Is that less than 1,000? No. So that means all these values up here are not going to work. We're just going to focus on these bars right here. How many people were less than 1,000 then? If we add 3 plus 3 plus 5 plus 4, it comes out to 15. Okay? So we have 15 out of the 35 people total in this survey. What the question is asking us is how many out of 420? We want to know how many out of 420. Okay, so we set the problem up as a proportion, and we do our cross product to make our prediction. We're going to multiply 35 times the x and get 35x. We're going to multiply 15 times the 420. Oops. And that's going to give us 6,300. And then we're going to go ahead and divide both sides by 35. And we're going to get what? 180. Very good. So we are expecting roughly around 180 people in the league to have less than 1,000 rushing yards. Okay, go ahead and get that copied down. Let's go to the last page. And I will have a picture uploaded tonight or a file uploaded tonight of all of this filled out. So if you were not able to copy something down or if you need to re-watch the lesson, the video will be posted as well on Google Classroom. Just make sure you're studying tonight. The test is tomorrow. All right, number 16. A survey of 400 randomly selected teachers in the county shows that 3 out of 5 teachers has their master's degree or higher. Select 2 statements that are true. 2 statements that are true. So we have a survey of 400 randomly selected teachers in the entire county says that 3 out of 5 teachers have their master's. Which 2 statements are true? The sample of the survey was 3 teachers. So remember, and I want you to write this off to the side, a sample is the same thing as who was surveyed. A sample represents who was surveyed. The population is the big picture, the big group. So this is saying that the survey only surveyed 3 teachers. Did they only survey 3 teachers? Yes or no? No. How many teachers did they survey? How many teachers did they survey? A survey of 400 teachers. So a survey of 400 teachers, that represents our sample. This is our sample. Our population is all the teachers in the entire county. So they're talking about the county. That's going to be your population. All the teachers that are in the county. So here, problem B, or answer B, says the sample is the survey of 400 teachers. That's who was surveyed. That is our sample. The population is the entire county, right? All the teachers in the county. That is true. Okay? Remember, your sample is who was surveyed. Who and how many. Who and how many were surveyed. That's your sample size. Your population is just the all group. Everybody in that area. Okay? Number 17. Identify if the survey method presented here is going to be a representative sample, meaning a fair sample, not biased. It's going to be a fair sample. If I send an Instagram poll to the school, is that a fair method of surveying? No. Why not? Because not everybody has Instagram. Not everybody has Instagram, nor does it mean that everybody who has Instagram is going to do the survey. That is not a fair method. Okay? Not fair. What if I personally call every 5th student on the school's roster? Is that a fair representation of the school?
No.
Why not? Every student on the roster. Everybody in the school is on the roster, yes or no? Yes. If you are at the school, you are on the school roster, and then I'm calling every 5th. That creates a systematic random sample. Yes. This is fair because it is systematic random. I'm not waiting for them to call me. I am contacting them. I am reaching out and personally talking to them. Okay, that is a fair sample. Mailing a survey home, is that a fair sample? Is somebody directly asking them the question? No. If someone is not directly asking the question, then you don't get fair feedback. Because just like an Instagram poll, can I ignore the mail? Yes. Plenty of times that we've emailed home to parents and parents don't respond. So just because we send it home does not mean parents respond to it. Same thing here. Okay? So not fair. Okay? This is voluntary response. I am hoping that they will go ahead and respond. Not a fair representation. Randomly selecting students from every homeroom. Is that fair? Yes. This is random selection. Randomly selecting. Every homeroom has kids being pooled and asked. So that creates a fair representation. If I ask the first 50 students that enter the school, is that a fair representation? No. Is that randomized? No. It's just picking the first 50 people. That makes it easy for me. And remember, easy is called convenience. That is not a fair method. It is not fair because it's a convenient and easy method. Maybe the first 50 people that enter the school are here for orchestra. Okay? So who knows whether maybe my survey is about orchestra and those first 50 people happen to be in orchestra. You don't want to cluster on one single group. You want to make sure it's spread out and you get variety. Okay? All right, problem 18. The following information represents the heights for a group of boys and a group of girls. We want to find the means and the ranges of each group and then make a comparison. We're going to find the mean and the range. Remember, mean. So let's focus on the boys first. For the mean, we're going to add all of them together and then divide by how many there are. So we're going to add 67 plus 65 plus the 71 plus 68 plus 68 plus 70 plus 68 plus 64. And then we're going to divide by how many there are. We've got 1, 2, 3, 4, 5, 6, 7, 8. We're going to divide that by 8. Okay, so if we add those together, what is it going to come out to? Say it again, 541. Okay, so we get 541. We then divide that by 8, and we're going to get 67.625 for the mean. This is the mean. Okay, the boys' range. We need to take the largest number. What's the largest number for the boys? 71. Then we're going to subtract the smallest number for the boys. What's the smallest number for the boys? 64. So when we subtract those, what do we get? 7. There's the range. Let's do the same thing for the girls now. We're going to find the girls' mean. Okay, so we're going to add their height. 60 plus 62 plus 61 plus 59 plus 65 plus 62 plus 66 plus 64. And we're going to divide that by 8. Okay, when we add all of those together, 60 plus 62 plus 61 plus the 59, 65, 62, 66, and 64, we're going to get 499. When we divide that by 8, we get 62.375. Okay, now their range. What's the highest height for the girls? 66. What's their lowest height? 59. When we subtract those, what do we get? 7. Okay, so if we make a comparison, their averages, I can say boys tend to be taller. on average. But I can also say that both the boys and the girls are consistent. They are equally consistent in their heights, meaning that they have a share spread, an equal spread. Make sure you are studying tonight. You have a study guide to study from.